right, I'm on page 356, and this is the beginning of lesson 2 for unit 7. This is plate tectonics and landforms. Okay, so your essential question: how do the movements of the tectonic plates result in landforms? By the end of this lesson, you should be able to explain how forces from tectonic plate movement and related processes deform Earth's crust and result in landforms. As always, you can do page 357 on your own. So let's go to page 358. What does the theory of plate tectonics explain? Well, Earth is divided into physical layers from its innermost deep, hot core to its outermost rocky surface. This outermost physical layer of Earth is called the lithosphere. It's a rigid, solid layer made of rock. The layer immediately below the lithosphere is called the asthenosphere. So let's see, stop, and outermost physical layer is called the lithosphere. The layer immediately below the lithosphere is called the asthenosphere. The lithosphere is divided into large moving pieces called tectonic plates. The theory of plate tectonics explains how lithospheric plates move around on the slowly flowing rock of the asthenosphere. And I've mentioned this before, and I'll mention it again. There are convection currents in the magma that's within the mantle of the Earth. And remember that warmer fluid rises, a little bit cooler fluid sinks, and you do have some circulation set up due to convection currents. Okay. What are some properties? What are some properties of tectonic plates? Well, the lithosphere is broken into about 15 major tectonic plates. There are some smaller ones, but there's 15 or so big ones, and they fit together like pieces of a puzzle. Or if you think of an egg that's been cracked, then you have a lot of different pieces that fit together to make that eggshell. Okay? Your lithospheric plates, your tectonic plates, differ in size, shape, density, thickness, and composition. Tectonic plates may be composed of oceanic or continental lithosphere, or sometimes the plate has both. Okay? So tectonic plates may be composed of oceanic or continental lithosphere or both. Continental lithosphere is thicker and older than oceanic lithosphere. Oceanic lithosphere is typically made of younger rock, and it is generally denser than continental lithosphere. Okay? Tectonic plates move slowly around Earth's surface and interact with one another. This causes the properties of tectonic plates to change over time. Okay. Okay, so I'm going to go back to an illustration that we looked at in lesson 1 because I want to talk about oceanic lithosphere, continental lithosphere. Okay, so this is on page 349 in lesson 1. And remember that the yellow lines are boundary lines for the lithospheric plates. So, for instance, this plate right here is the South American plate. And you can see that it has the land mass, the continent of South America, but it also includes some of the ocean floor underneath the Atlantic Ocean. So this lithospheric plate, known as the South American plate, has both continental lithosphere, okay, and oceanic lithosphere. This plate over here is the African plate, okay? Its boundaries are right along through here, okay? The African plate, same thing. It's got continental lithosphere, sometimes we just say continental crust, and it also has oceanic lithosphere or oceanic crust. Okay, most of your major lithospheric plates A lot of them have both continental crust or continental lithosphere and oceanic. Okay, so it has both types of lithosphere on the same plate. All right, back to page 358 and 359. All right, so one more time. Your lithospheric plates differ in size, shape, density, thickness, and composition, meaning what kind of rocks are they made of. Tectonic plates may be composed of oceanic or continental lithosphere, or oceanic and continental crust is what people sometimes say. Okay, continental lithosphere is thicker and older. Oceanic lithosphere is younger and denser. Okay. Okay, let's go to page 359. And it says, what types of stress are related to the movement of tectonic plates? Tectonic plates shape Earth's surface by slowly forming and changing crustal features such as mountains. Tectonic plate movement puts stress on rock. 3 types of stress cause deformation. Deformation is the bending, tilting, and breaking of rock, and it changes the shape and size of features on and below Earth's surface. All right. So there are 3 types of stress that cause deformation or deformation. Okay. And deformation or deformation is bending, tilting, breaking of rock. All right. Types of stress. First type of stress we have that we can put on rocks, type of stress number 1, is compression. When you compress something, you are squishing it, squeezing it together, okay? A metal spring gets shorter when its ends are pressed together. It is compressed. Compression is a stress that squeezes or shortens a material. Compression can cause folds as rock is squeezed and shortened. For instance, imagine pushing on both ends of a dried fruit strip. The fruit strip will bend and fold. Okay? Folding also occurs where Earth's lithosphere is less rigid. Rock that's less rigid bends instead of breaks. Compression can also cause breaks in rocks, which are called faults, where Earth's lithosphere is more rigid. Okay, so what is compression? Compression is a stress that squeezes or shortens a material. Compression can cause folds. Okay, compression can also cause breaks, known as faults. Okay, so over here, describe in 1 or 2 words what is happening to the rock layer in each diagram. Well, this is being compressed. It's being squeezed and shortened. So this is compression here. Okay. Second type of stress is tension. Tension is, I don't know if you really want to say if it's the opposite of compression, but I guess it sort of is. Okay, it says what happens when you stretch a rubber band? It becomes longer and thinner. Tension is a stress that lengthens a material or pulls a material apart. 2 plates moving away from one another cause tension. When tension is greater than the strength of the rock, it can deform the rock by breaking it. Faults form when rock breaks. So this one can also result in the formation of faults. Okay. So what is tension? Tension is a stress that lengthens a material or pulls the material apart. Okay. It can deform rocks by breaking them, forming faults. Okay. Okay, and this can occur when you have tectonic plates moving away from one another. Okay. Compression you're generally going to have when tectonic plates are pushing against each other or coming together. Okay. And then we have shear stress. This is type of stress number 3. Okay, and I'm actually going to go back up here and put 3 types of stress. Okay, so 3 types of stress: compression, tension, and shear stress. What happens when you push 2 blocks of modeling clay together as you move them in opposite directions? The blocks become more twisted. Shear stress causes material to twist or become distorted. It can occur when 2 tectonic plates move past one another. The rocks don't move smoothly, instead they grind against each other. Okay. So, shear stress causes material to twist or become distorted, and it occurs when tectonic plates attempt to slide past one another. Okay. The plates wind up grinding against each other. All right, so let's finish our little activity over here. This particular rock formation is under tension because it's being pulled in different direction. This set of rock layers is undergoing shear stress because one rock layer is trying to slide in the opposite direction from another one.